So I wanted to continue where we left off in Chapter 9, talking about quadratics and parabolas. I'm currently looking at the Chapter 9 core packet, and this is just page 1. I wanted to remind you that there were basically 3 ways that we were writing quadratics. One was in standard form, which was y equals ax squared plus bx plus c, right, where a, b, and c were all numbers. Another was in factored form, where we had something like y equals x either plus some number or minus some number times x and then plus some number or minus some number, right? So plus a different number, possibly. And then the third way was in vertex form. So this one looked like y equals a x minus some number. This was the horizontal shift. Let's call it h squared. And then this number was the vertical shift. So we could say it plus, let's make up a number k, letter k. All right, so this was just a standard way for it to be written. Call it standard form. And we can plug in, we can use the quadratic formula here. It's useful for a few different reasons. This factored form was most useful for x-intercepts. So factored form, x-intercepts. And this is vertex form. Vertex form obviously is most useful to help find the vertex. Right, so looking through a few of these problems, I don't want to do all of them. I'm going to just mainly focus on x-intercepts and y-intercepts. And on B, the first thing I notice is it's asking for both x-intercepts and y-intercepts. So I want to mention x-intercepts. We always know that y is equal to 0. That's the first thing that we want to focus on. And it looks like y is equal to 0 here, so there are 2 spots, that one and this one. This is, looks like 3, 0. And this x-intercept is negative 1, 0. Right, and pointing out that for an x-intercept, the y value is 0. And then for a y-intercept, the first thing we want to recognize is x is equal to 0. Which means if x is 0 right here, and the graph crosses at that part on the y-axis, which would be 0, negative 3. 0, negative 3. Notice for this y-intercept, x is 0. So I just want to go through, look at some of the other problems that ask for x or y-intercepts. And it looks like C is one of the first ones. C is asking for a y-intercept, which means I want x to equal 0. So all I'm going to do is plug in y equals something squared minus 2 times something minus 3. And the something that I'm plugging in is 0 in both of those spots. So I have y equals, what's 0 minus 3? That's going to be a y value of negative 3. Okay, and just like before, we could write it as a coordinate if we wanted to. All right. This is in standard form, but I'm looking for x and y intercepts like I mentioned before. And right here it says, well, I'm talking about x-intercepts. And like I mentioned before, x-intercepts, the easiest way to write them or to get them is in factored form. So that's what I'm going to go after. X-intercepts, I'm thinking about factored form. Factored form can be written like y equals, and then a couple of parentheses like that. And if I saw negative 1 as one of the x-intercepts, I would have thought x, and if it's negative 1, that means one of the factors would be x plus 1. And the other one is positive 4, so that means the factor would be x minus 4. Okay. Continuing on, it looks like moving on over here, they're asking for x-intercepts again. And this is the other way around. This time they're giving us factored form, which is pretty nice because in factored form, it's pretty easy to get x-intercepts. We just have to say y is 0, and then the 0 product property tells us we can set this guy equal to 0, and we can set this guy equal to 0, right there, either one of them. So this one's going to produce x minus 3 equals 0. That's going to be x is 3. And x plus 1 as a factor produces x equals negative 1. So it looks like 2 x-intercepts in this case. Letter H is asking for x-intercepts as well. And this is in standard form, which is not a great way to be able to find x-intercepts. So when it's in standard form, my first option would be to probably try to factor or use the quadratic formula. And luckily, I think we've already done this problem. This one does factor. We do, like I said, want to set y equal to 0. And then it does factor using the x method. What multiplies to -3 and adds to -2. I think we have to have an x and an x here to multiply to be x squared. And then because it's multiplying to a negative, we need a positive and a negative. And 3 is actually a pretty nice number because there's only one set of numbers that multiplies to 3. That's 3 and 1, or the other way around, 1 and 3. So which order does it have to be in? Looks like we need more negatives. So it's going to be a 3 there and a 1 there. Which means the x-intercepts are x equals, that thing is x plus 1, so it's going to be -1. And this one is x minus 3. If it's equal to 0, then it's going to be x equals +3. Okay, and it looks like we have one more problem that's asking for a y-intercept. It's at the bottom. So y-intercept is on that letter. Right? So how do you find a y-intercept from vertex form? So vertex form obviously isn't the greatest way, but for a y-intercept, we always want to think the other letter, x equals 0. So I'm just going to plug a 0 in that spot. Right? So we have y is equal to, and 0 minus 1 is going to be -1 needs to be squared, and then 4 needs to be taken away. So anytime we square a number, it's always going to be positive. So -1 times -1 is y equals, it's going to be 1 minus 4, and so y equals -3. And if I wrote that as a coordinate, of course, I said originally x was 0, so that would be 0, -3. There's my y-intercept from vertex form. I will post another video. It'll help you find a vertex, and it'll also talk about whether parabolas are opening up or down.